Welcome to another instructional video from OWL, the wise choice in fiber optic test equipment. I'm Professor Jim Powers. This video will help demonstrate how to check your WaveTester Optical Power Meter for proper operation using a WaveSource multimode light source. Patch cables in test equipment should always be checked prior to testing to ensure accurate and reliable test results. Usually a good time to do this is at the beginning of every testing day. In this procedure, we will be using the WaveTester Optical Power Meter and the multimode port on the WaveSource optical light source. You'll notice that there are two patch cables and one mating sleeve used in this procedure. Since this is multimode, one of the reference cables is wrapped around a mandrel per testing standards. The mandrel wrapped reference cable will be used to zero out the test equipment as well as connect the WaveSource into the link under test. The second cable is used to connect the WaveTester into the link under test. And the mating sleeve is just used for this procedure only to connect these two cables together for the purpose of making sure that they're working fine. Okay, one main thing you need to make sure of when selecting patch cables for testing is that the connector types are correct. You need to make sure that one end of the patch cables connect into the testers themselves, and the other end of the patch cables must be able to connect into the link under test. Now, they don't have to match. It could be SC to LC. But in this case, we're just going to assume that everything is SC, including the patch panels. The first step is to power on the testers. So we press the on button on the WaveTester and the power button on the WaveSource. Now on the WaveSource, you'll see that the multimode port is lit by default. You may not be able to see it very well on the video here, but the LED here is red, which indicates 850 nanometer output. Now on the WaveTester, we'll see a reading on the screen. We see that it shows 850 nanometers, and it also shows dBm, which is an absolute power measurement. However, we also see the word low. What low means is that there's no amount of measurable light coming into the photodetector. This is because the detector is covered by a dust cap. If we remove the dust cap, we will see that we get a reading. However, this reading is a very low power reading, and what this means is we're measuring ambient room light. Obviously, there's no connector plugged in here, so it's measuring something. It's measuring ambient room light. This is a typical power level for ambient room light. So whenever you disconnect your fibers and have the detector port open like this, just remember that the reading you're getting is ambient room light. The next step is to check the multimode reference cable here, the mandrel wrapped cable. So first we plug this cable into the multimode port on the WaveSource, and we plug the other end into the WaveTester Optical Power Meter. Okay, what we see on the screen now is the reference level. Okay, in this case it's minus 20.3. Okay, this is actually an acceptable power reading. Our target value is around minus 20 dBm. Now the reading could be a little higher or a little lower, as it is in this case, but as long as we're not exceeding minus 21 dBm, we know that this patch cable is sufficient for use. Okay, so what we can do is, we know this is a good reference level, so let's just temporarily zero out this wavelength. Okay, notice the reading switches to dB, and it says 0, so 0 dB. So this means minus 20.3 is our reference level, and it's where we're starting our measurement at 0 dB. Now, it's always a good idea to check both wavelengths, especially if we're doing a dual wavelength test. In this case, 1300 is the second wavelength. So what we want to do, first of all, is press the wavelength button on the WaveSource. We'll notice it flashes briefly and then goes to green. Okay, now what we want to do is make sure that we change our units back to dBm, and then we also change the wavelength to 1300. Okay, again, we want to see a power level that's around minus 20. In this case, it's just a very little bit below minus 20. So this is also confirms that this reference cable is good for use, and it also confirms that the wave source is in proper calibration. Again, we can zero out this wavelength. Notice it says 0 dB. Okay. Now, one interesting feature about the WaveTester and the WaveSource is called auto mode. Now, we can set both units into auto mode so that we can test both wavelengths simultaneously without having to press buttons to switch wavelengths. So on the WaveTester, we simply press and hold the auto button. Okay. Now notice it's switching between 1300 and auto. Okay. What this means is that the detector is scanning incoming signals for an auto testing signal, but is not getting one yet. On the WaveSource, to set the WaveSource into auto mode, we press and hold the auto button. We watch the indicator LED to begin flashing, and then we remove our finger. And we watch the WaveSource for a few seconds just to make sure that it's switching back and forth between green and red. Okay, going back to the power meter, we will see that it's not saying auto anymore, but it's switching between the two wavelengths. So there's 850, 1300. 850, 1300. And notice both of the readings are saying 0 dB. What this means is that we have successfully zeroed out our equipment, and the patch cable is good, and the equipment is working properly together. Now the next step is to check this second cable to make sure it is okay. And to do this, we simply remove the patch cable from the detector port, and notice we're getting a low power level again. Remember, we're measuring ambient room light, and because we're not getting an auto testing signal, it's switching between 850 and auto. We plug the mating sleeve on the end of the reference cable. We plug one end of the second cable into the other end of the mating sleeve. And finally, we plug the second cable into the detector port on the WaveTester. Okay, notice that the WaveTester has now reacquired auto mode, and it's switching between the wavelengths. Okay, so we see 0.13 dB for 1300 and 0.43 dB for 850. Okay, what this means is that there's a little bit of loss in this cable and this mating sleeve. Okay, what we want to try to do is make sure it's no more than half a dB, because the amount of loss in this cable is actually added into our measurement. That's why we want to make sure that it's okay to use. But in this case, we're less than half a dB, so these cables should be sufficient for use for testing. If the power level falls below the acceptable power level range, debris such as dust, dirt, or finger oil may have collected on the connector end face or in the equipment's optical ports. Thoroughly clean and inspect all connector end faces and equipment's optical ports according to industry standard cleaning procedures. Several cleaning cycles may be required. Keeping connectors and optical ports clean at all times helps to keep test equipment in good working order and proper calibration, ensuring accurate and reliable test results. When not in use, dust caps should be kept on fiber connectors and optical ports to keep debris from collecting on the surfaces of the connectors and ports. During testing, it is highly recommended to clean and inspect both connectors and optical ports every time a connection is made. Failure to properly maintain your test equipment could needlessly result in costly repairs. For example, over time, repeated connector insertions into a dirty optical port could grind the debris into the optics in an equipment port. This type of damage is permanent and cannot be repaired in the field. If the problem still exists after thorough cleaning and inspection, the patch cable may need to be replaced. Patch cables are typically rated for a few hundred connector insertions, but can prematurely wear out or become damaged if they are not properly handled and maintained. If the power level is still too low, even after patch cable replacement, contact OWL Technical Support for assistance. This has been another instructional video from OWL, the wise choice in fiber optic test equipment. For more information about additional instructional videos or OWL fiber optic test equipment in general, please visit OWL's website at owl-inc.com. I'm Professor Jim Powers. Thanks for watching.